Okay, so here we let P represent the idea that x is an even number greater than 10. So, right, x so far could be anything that's greater than 10 and even. So 12, 14, and so forth. And Q represents the idea that x is not evenly divisible by 4. So multiples of 4, right, 4, 8, and so forth, are all divisible by 4. However, we're looking for numbers that are not evenly divisible by 4. So, for example, we could have 1 and 2 and 3, right? All these will give you fraction results, not 4, because, well, 4 divisible by 4 is 1, or any multiple of 4 for that case. So we have 5 and 6, 7, and skip 8, and then keep going where we skip multiples of 4. Now, we want to know for which values of x is P and not Q a true statement. So all that means is that for this to be a true statement, what has to happen? Well, P initially has to be true and Q has to be false, right? Because we have not Q here. This is the inverse of Q. So if Q is false, right? Well, then not Q must be true, right? And that's just, we're looking at that because here, in order for this to be a true statement overall, they both have to be true, right? P has to be true and Q has to be, right, or in this case not Q, has to be true. So what does that mean? Well, here, that means we can leave P and assume that x is an even number greater than 10. So this is going to be true. But we also have to assume that Q is going to be false, again, so that not Q will be true. And so if Q is false, then what do we have? Well, when Q is true, we have x that's not evenly divisible by 4. So by making it a false statement, that means that x is evenly divisible by 4. So we're looking at all the numbers, right, the even numbers that are greater than 10 and also multiples of 4. In that case, right, when they're both true, the overall truth value of the statement is true. So for example, 12 is greater than 10, it's an even number, and divisible by 4, and we keep going. 16 will be the next number, and so forth. Essentially, all the multiples of 4 work for this statement. Alright, thanks.